Alright, 8th graders, today we're talking about rewriting formulas. So, we're taking what we know about solving equations and using it to rearrange formulas to make them the most useful. So for example, in science, if you were taking measurements of, let's say you had the area of a triangle and the base of a triangle, and you're always looking for height, you wouldn't want to solve that every single time. So let's say you had 100 problems to do. You wouldn't want to solve it every time. You would certainly want to solve for height one time and then just be able to fill in the area and the base. So that's exactly what we're going to do on this problem. To solve for h, we have 1/2 times b times h. That equals a. So if I divide by 1/2 b, that gets rid of all of it. So I have a divided by 1/2 b equals h. You could have done that in 2 steps, divide by 1/2 and then divide by b, but you can do it in all one step as well. The only problem with this solution is that we have a fraction within a fraction, this 1/2. We don't really like it. So dividing by 1/2, no matter what we're dividing by 1/2, we keep change flip is the same as multiplying by 2. So I can rewrite this as 2a over b equals h. Let's try another one. Solve the formula for the perimeter of a rectangle. P equals 2 times length plus width for the width w. So we first have to undo our parentheses, and we can do that by either distributing the 2 or immediately dividing by 2. I would suggest immediately dividing by 2, because then we have P divided by 2 equals L plus W, subtract L, so W equals P divided by 2 minus L. It wouldn't be wrong if you distributed the 2. It would just take more steps to solve. So I always get rid of whatever should be distributed first. Alright. Not a formula this time, but just an equation. Solve y equals 5x plus 7 for x. So if we want to solve for x, we would subtract 7. So we have y minus 7 equals 5x, and then divide by 5. Now that's divide everything by 5. So you have to keep y minus 7 in the numerator and divide everything by 5. On the next one, we're solving for x, so we'd want to add 8. Now, on this one, we can combine negative 4 plus 8, and that gives us y plus 4 equals 3x. But then we divide by 3, divide the whole thing by 3. So if you can combine like terms, you should combine like terms. Otherwise, it's not the simplest form of the equation. Transforming equations containing only variables. So there's nothing different about this. If you imagined A, D, and C as numbers and B as the variable, it's the exact same thing that we're doing. So we're going to add D to both sides. So we have AB equals C plus D. Then we're going to divide by A. Divide the whole thing by A. It seems more difficult when you have only variables, but just imagine them as numbers. Same thing for the next one. We're solving for P, so I would subtract M. Now I have, don't forget this negative, negative HP equals D minus M. So I'd divide by negative H. And P equals D minus M divided by negative H. Alright, the formula C equals 5/9 F minus 32 gives the Celsius temperature C in terms of the Fahrenheit temperature F. Transform the formula to find the Fahrenheit temperature in terms of Celsius temperature, then find the Fahrenheit temperature when the Celsius temperature is 30 degrees. So if we found a bunch of Fahrenheit temperatures, or if we found a bunch of Celsius temperatures and wanted to change them to Fahrenheit temperatures, you'd have to fill in a number for C and then solve it every single time. So if you had a bunch of those problems to do, it would be in your best interest to solve first for F and then fill in all those numbers. So here once again I have something to distribute, and I would get rid of that first. So I would divide by 5/9 or multiply by 9/5. Remember we talked about dividing and multiplying by the reciprocal is the same thing. So 9/5 C, and that would be like C over 1. So you can say 9C over 5 equals F minus 32. Add 32. So F equals 9/5 C plus 32. And then, if the temperature is 30, we're going to fill in 30 here. So 9/5 times 30 plus 32 is 86 degrees Fahrenheit. Another real-world problem, you can use the number of chirps N a cricket makes in 1 minute to estimate the outside temperature F in degrees Fahrenheit. Transform the formula F equals N divided by 4 plus 37 to find the number of chirps in terms of temperature. How many chirps per minute can you expect if the temperature is 60 degrees Fahrenheit? So here we're solving for N. So I would subtract 37 from both sides. And then multiply by 4. To multiply by 4 after you have some things subtracted or added together, they have to go in parentheses. If you do not have these parentheses, your answer is incorrect because you would only be multiplying one piece by 4 instead of both pieces by 4. So N equals 4 times F minus 37. And if it's 60 degrees out, fill in 60 for F. So 4 times 60 minus 37 gives us 92. And that was chirps. on the last page, I would like you to go ahead and try 6 through 11. Come to class with any questions that you might have. We're going to go over these to make sure you got them correct. Have a great night.